Righto guys, we're going to start the next job on this powered slider. And it's going to be the slides here and here. So I call this the chuck side slide, and that's the drive side slide. We've got two of them to make, and they're quite a bit different from each other. This one here is the chuck side. Fairly straightforward, this one. We're making this up over a bit of 50 by 25mm flat. We've got a dovetail that we need to cut into that, and a series of holes that we need to drill and counterbore, and some top holes to drill and tap for the upper bridge that's going to go across. The drive side's a little bit different. This is one that we're going to have the dovetail so that we can adjust it to, not actually adjust it, but to actually tighten up to lock the main slide in place while we're doing the sliding action. So a little bit more work in this one with the sliding that we need to do. I've taken this idea off the cheap Chinese boring heads that you might see. This is the similar, or the same system they use for locking up their slides on the boring heads. So because this isn't a operational dovetail, so to speak, it's going to be locked in place. This is probably the ideal way to go. So why reinvent the wheel? It works well. With this one as well, we've got a slot that we need to cut out, same as what we've done in the housing to clear that crank arm. We've got a series of holes that we need to drill and tap for the grub screws that are going to apply that pressure onto that slot to lock the slide plate up. Once again, we've got holes that we need to drill and tap on the top of that to mount that upper bridge. And obviously the holes that we need to drill and counterbore to lock that onto the plate. I'll just quickly show you, that's the detail for the main slide that's going to work in those dovetails, which is going to mount the slotting ram slides on. So they're all going to be a keyed fit into here the way that we're going to machine up this plate. So a bit of work in this bloke when we get to it. We've also got a fair bit of machining to do to actually put the nut into place. It's going to allow that to be indexed up and down. So that's what we're up for next. A little bit of work in this one, but it'll be interesting. My plan is that I will finish machine all the outside envelope dimensions to size, and then we will roughly machine out the dovetails. I'll mount them onto the housing, and then I'll dowel them into place, and then we'll do the final machining for these dovetails with these slides actually mounted on the actual housing, so that I can make sure that I can get everything dead square, particularly to the base. So it's going to be the easiest way to go about doing that job, and that way any little tolerancing or squareness issues that I've got in the housing, I can take those out when I do that final in situ machining. So this is a bit of stock that we're going to be using. I've cleaned this up quite a bit. This was once again from a scrapper. This was in the dirt and had dried up worms and all sorts of rubbish on it. So that's what we're going to be using. So we're going to head over to the bandsaw first. We'll cut this to length, and then we'll get set up in the milling machine to start machining those outer envelope dimensions, and we'll set up for roughing out the dovetails. All right, well, let's go and get over to my favourite machine, the bandsaw, and we'll make a start. All right, guys, we're back again. We bandsawed these out to length. I've left a couple of mil on each end to end mill off to size. Got the first one set up in the vise. We'll start machining that out. Something I did want to talk about is the stresses that materials, when they've gone through a hot work process, tend to hold. This has been put through a hot rolling mill, and after the final rolling process, it flies out usually into a big cooling A-frame, which has got air at a fair rate coming up through a series of grids that this stock is sitting on. So it tends to chill down the outer surfaces fairly quickly. The inner core will tend to slow down a lot, or cool down a lot slower, and tend to relax out a lot more. So you'll end up with stresses fighting against each other between the outer boundaries and the inner cores. And when we start the machining operations, you'll often see that starting to come out, particularly with longer lengths. You'll start to see the material start to bow. And that's those stresses relaxing out, fighting against each other. The resultant is the material will move. When that does happen, you need to set your machining sequences up in a way that you're going to work with that movement and try and take it out. You'll try and even the amount of machining you're doing around on each side, lifting up, turning over, remachining. If you've got the bow in it, often you'll pack underneath it, machine it flat on the top again, flip it over, try and take the bow out. Long slender shafts are an absolute classic. Cold roll stock, which has had that final cold roll operation done on it, whether it's a drawing operation or a rolling operation to give that nice bright finish, that tends to put stresses more so into material than what black stock is. So if you've got long slender shafts, you will start to see them move. The chrome moly steels, your high tensile steels, your 4140s and 25s and 26s are probably the worst. They'll come in a peel bar stock form, and they tend to move more than anything. And I've had long shafts that you fight the entire time, and I would tend to flip from headstock to tailstock, headstock to tailstock, to try and work the stresses around as best you can. And sometimes you get to a point where it just won't happen. You've got to straighten it up and send it out for stress relieving, and come back and try on it again. So just be aware that steel does tend to move if you are machining it, particularly on long slender lengths. Not so much of an issue with the short stumpy stuff we're doing here, but just something to watch out for as you are machining, and work with it. Right, so we're set up for this machining operation. This is measuring up a nominal just under 25 mil. Final size on this is 23. So I'll take the minimum amount I can off on one side, flip it over, and we'll see how we work out on the other side. Then we'll do the edges. And I see that my variable frequency drive has just flicked off and flicked back on again, which as I mentioned in one of my previous videos was a sign that it's starting to pack it in. And as I said, I've had these ones for about 5 years. I had this on another machine that I don't use very frequently, and I burnt the last VFD out on this mill, and I've taken that VFD off that other machine and I've put it over here. So expect to see another VFD change out fairly soon. We'll see how we go. All right. Let's start some machining. Well, that machined out reasonably true actually, so we'll take another cut on that. I think I'm going to have to change these tips over. I've had these in for a long time, but let's see if we get a better finish on the other side. Cutting the other way. That is a shocking finish on that. I'll change those tips out, and we'll come back. Okay, changed my mind. I didn't take the tips out, up the speed, and put a bit of cutting fluid on there, and it's a mirror finish. There you go. I've just had a look at my drawing. I realised that I've got to take these back to 36mm in width. So I've got 14mm that I've got to take off the edges, so what I might do is I won't continue on with these faces. I'll get the edges machined back to size first, then we'll come back and do the faces just in case we get any lateral movement on this material. So I'll reset up and we'll start knocking off into the ends or edges. I'll change this cutter out for a smaller cutter as well. So this one for our finishing. Righto, we've set this up. I just run a test cut down just to see how evenly it cuts, and I'm pretty happy with that. Yeah, so I've got roughly 7mm on each side to take off, so we'll take off 6mm a side, we'll flip it around, and we'll come back to size. I'm going to set these up probably on the surface grind. I'll do the final surface grind on all faces on that. So we'll leave ourselves about 0.2 of a mil to clean up on the surface grinder. Right, let's get into it. Right, we'll put a bit of lubricant on that, coming up to the 6mm. I just want to see what sort of a surface finish I can get out of this. So we'll just take a small cut. That horrible noise you can hear when I'm cranking the table back is the drive for the table, and going through the back ears. It tends to make a horrible noise when I'm doing it. That's about a 6 there. Right, let's see what sort of a finish we can get. Yeah, it's not bad, it's not great. If it's sort of motley, I'll try bringing it back this way with the cut. Sometimes you'll find running the feed the opposite way, you'll end up with a better finish. I'll put a bit of lubricant on there again. No problem feeding this way as I get showered with chips. Yeah, much better finish, and you may not have noticed on the camera, but I'm getting what I call an onion ring cut, which is a back cut, because the head's not exactly vertical to the table or square to the table. It's only by a few tenths, but it's enough to give it a little back cut, which does that final cleanup as the front cut takes the majority of the material off. So yeah, it's a reasonably good finish on that. All right, I'll take that over to my my grinder, where I've got a sanding disc on that, and we'll just take off those burrs, and we'll come back and set it up the other side. Right, burrs are off, they're easy to knock off with a file. Just put a small light chamfer on it. So I'll flip this over, put it back down on the parallels. I always like to give it a quick run over before I actually start taking a cut to depth, just to see how parallel it's looking from the face that I've just machined. So I'll have a quick look at that now. Alright, that's pretty good. That's cutting heavier on the ends and shallower in the middle there, so it may have been through the machine. We've got a little bow in it, but that's fine. We'll go down the 6mm again, and then we'll machine the other faces, and then we'll do the final machining on them and set them up into the surface grinder. Just do a very quick check on that. Yeah, down to 42.15. Right, down to 39, so I'll take another mil off that, keep 2mm up on our final size so I can do the final machining. Alright, that's a reasonable sort of finish. I don't think I'll go that way again. I've got chip shad all over the workshop, and that's got a pretty gnarly burr on that. I'll have to take that off with the belt on the grinder. Alright, I'll get this flipped over to the other face, and we'll start working on those, and we'll work this around till we get it down to about 0.2 over nominal size on all faces. Then I'll set up in the surface grinder, and we'll take 0.1 off each side and tidy up that face. Alright, we'll just lightly clean up this last side, and I might make a change to the machining operations on this. I might try and pre-rough out as much of that dovetail as I can before I go to finish. I just have that concern that it may bow a bit, but we'll see how it looks. And the difficulty is going to be holding it after that, so I've got to make sure that when I do machine or rough that dovetail in, that I give myself some faces that I can clamp onto to get that final machining done. But we'll set this down on the parallels. I'll just do my quick little whisk past to see how that's sitting on the parallels. Righto, so I've got that sitting dead flat on those parallels. They've nipped up nice and tight, but you can see we're touching on the ends only, so it has done a bit of a bow like that, and that's what I'm a bit concerned about when I do rough out this dovetail, that it is going to bow further. So I'll just take a lick off this. We'll take as much meat out as we practically can for roughing out that dovetail. Then we'll come back and do the final machining then, I think. we've got some shocking vibration now. That I'll slow it down, just do one more cleanup pass on it. Right, we're getting a shocking surface finish, vibration really bad at those higher speeds, so I've backed the RPM off and increased the table feed rate, and yeah, we've got back to a good finish there. Alright, I'll reset this up on parallels a little bit higher so we can get access to start roughing out those dovetails. Let's just see how much movement we get out of this too when we do that. Alright, we'll come back when we've got that set up ready to go. Right, I want to clean up the final mill to depth, or roughing depth, with the high speed steel, or I'll use a carbide end mill, and then also the edge here will come back another millimetre, so that'll be the continuation or completion of our roughing. What I'm going to do is I'm going to back the vise off and then redo it up again. I just want to make sure that if there's anything holding that down, if it has wanted to move, if we do all our final machining and we back the vise off and the thing goes ping, we're in a bit of strife. So let's get any movement out now. So we'll machine that roughing slot out, and then we'll give it another lick across the top, then we'll flip it over, do the other face, then we'll do the edges. Right, so we've got our high speed cutter in at the moment, so we'll come half a mil, and we'll do another half a mil, and get that off to a finished roughing size. Right, while it's set up like this, I think we might end mill to length. I'm going to change the tool out on this because these edges here are really badly nailed up. So it's going to give me a pretty poor surface finish across there. So I'm just going to whack in a carbide end mill just to run those ends. Change of mind. I think I might finish the ends off once we've got everything knocked over and we've got everything squared up. I don't want to have this cusped up and I've machined the ends and we pull it back and they're no longer square. I need them to be square for the bridging plate that's going to support that, that adjusting screw. So I might take that out. We'll flip this over and we'll give it a machine on the back. Take it down to our finishing size plus about 0.1. We'll flip it over and then we'll machine this. That way at least we know that all these faces here are going to be parallel with each other. That's 10 times better. Right, let's come back the other way. Sorry guys, got to turn the camera on, but we've got a pretty good finish across that face now. We'll flip that over. I'll just measure that and see what that looks like for parallel. Alright, so 23.85, 23.8483, so 0.02. So I'll flip this over, get it set up again, give it a lick across the top, and we'll give it an M mill. We'll bring it back to size. Well, back to size ready for grinding anyway. Alright, so we flip this over. I've already taken a lick just to confirm the parallelism on this, and it's within 0.01, so I'm pretty happy with that. I've also changed my cutter over as well, so we're going to take about half a mil off this from where we are at the moment. We're sitting at about 23.7. Nominal size or finished size is 23 mil, so we'll take off the half mil. That'll give us 0.2 of a mil to go on the grinder. That'll give us about 0.1 on each side to clean up. So we should be pretty close to 23.2 on this now. 23.22. At this end of the show. Oh, 23.23, 23.22. So we're still holding within 0.01 of a mil on parallel. I'll now set up the end mill and we'll just clean these ends up to length. Then we'll flip it over and we'll finish the sizes off to within 0.2 of a mil. And we'll put that on the grinder and just give them a lick. Alright, we'll do that now and we'll come back when we've got the end mill in play. Right, we'll just touch off and give this one a lick. We've already given that one a little bit of a lick before. Just double check that, get out. Oh, 37.57. So that's dead nuts parallel. just like in the middle. Yeah, 58.01. Couple of tenths of a thou. All right, we'll set it up and we'll give this face the final machine, our roughing machine. Get that down to within 0.2 of a mil, ready for grinding. So we'll come back for that. Right, guys, we're back again. I finished off this other slide. It's amazing when you do one how quickly the other one comes up. So I knocked it up in just over half an hour. So that was a quick run. What I want to do is I want to pre-cut the slot into the drive side slideway. Reason being that I want to try and get as much of this machining out of the way as I can before I do the final grinds, just to make sure that everything is dead flat when I'm finished. What I'll do after I've cut this slot is I want to grind the two sides back to width and set that up so that I can then drill and counterbore my holes. I want to have an exact edge to work to. I'm running really close to these edges at the moment, so I want to know exactly where I am before I start those holes. Everything's really tight. So I've done a little stick or wire setup just with a bit of blue tack. Just something I have sitting on my wall when I need it. It's a nice easy thing just to stick in place and just run it down. So all I've done is I've run up and down the line that's on this side. We'll get that cut down to depth, cut out a fair bit of the guts, then we'll turn it around and set this line up and then finish that off to depth. So we'll make a start on that now. Alright, same plan as what we did last time. We'll just rough it out with the carbide bits. Get all that gutsy stuff taken out with those. Then we'll come up with a carbide end mill and we'll finish them off. Give that a nice finish. Marking these out, I just back this up against the housing, and just with a scribe I just mark down the existing lines just to transfer onto this. So that was, I should say that existing cutout, and transferred it onto this bloke. So now I've got to go about 3 mil deep. We'll go a tad more because we do have to grind this face back. Oh, it's got really nice. Alright, I'll rotate this around now to cut this edge, and that's the slot finish. So I've gone 3.1 deep. Now I've got a maximum amount of 0.1 that we're going to take off that top surface when we grind it. So it's only for clearance. It's not a critical depth. All right, I'll get that turned around and we'll come back. It's probably a bit dark, but anyway, we'll get a start on it. Alright, we'll unbolt that and unclamp that. We'll go and try it over on the. Alright, so That's how it's going to be looking for that crank arm to come through. That's what they look like up in front. So obviously we've got a fair bit of work to cut with the dovetails. We've got to do our drilling and counter boring to be able to mount our socketed cap screws in place, and then we've got the bridge that's got to go over the top. So I've got some drilling and tapping to do in these, so 3 in each. So what I'll do, as I said, I want to just grind these edges on both blocks so that I know exactly what the width is, because I'm cutting them pretty close to the wind to get these socketed cap screws in. I want to know exactly where I am. So that's looking good.